Okay, guys, this is I'm not sure what attempt this is to get this thing right. I hope it goes right this time. So, what we're supposed to do is go over some review concepts to get you ready for next year because we didn't get to finish the class or whatever. What we want to talk about are radians to degrees and degrees degrees to radians. Okay. And if you had this year, we did talk about this in class, but it's going to be very useful next year because in calculus, a lot of the questions will be given vice versa, radians, or maybe sometimes in degrees. Okay. So we'll just jump right here and do a few examples. There'll be a couple pauses in the videos. Don't worry, it's just when we change screens on this program we're using. That's pretty much the only way to do it. Okay. So we'll start with a easy one. We'll go with 3 pi over 4. And this is clearly a radian measure because it does have pi in it. So to go from radians to degrees, you just simply sub in 180 for pi. So this will be 3 times 180 divided by 4. And 3 times 180 is 540. And 540 divided by 4 is going to be 135. Okay, so that's pretty much an easy one. I'm going to try to erase this up here and do another example up here instead of pausing and changing the screen because it does seem to do better when you just keep going on the same screen. So I do apologize for that. I wish there was an easier way. I'm sure there's an easier way, but I just haven't found it yet. Okay, so we'll do one more example, and then there'll be like a slight pause, and then I will go to the next screen, and we'll talk about going from degrees to radians. Okay, so here's our next radians to degree example. Let's go with 2 pi over 5. 2 pi over 5. So that's where you, once again, you just sub in 180 for pi. So this is 2 times 180 over 5. 2 times 180, of course, is 360. 360 divided by 5. I'm sure all of you remember what that is. 360 divided by 5 is going to be 72. So that's 72 degrees and 135 degrees. Okay, so that is both. That's two examples of going from radians to degrees. Okay, guys, now we're going to go from degrees to radians. Going from degrees to radians is just useful in trig. Sometimes it could be useful in calculus when the problem does involve radians and you don't want to change all these different measures. Okay, so we'll start with an easy one. We'll start with 300 degrees. So to go from degrees to radians, you're going to use the conversion factor pi over 180. Because if you want a radian, you want something with pi in that measure. Okay, so this is going to be 300 times pi over 180. And then it's just a matter of simplifying because in calculus, they're going to want all this stuff simplified. So I'm going to chop off my zeros. Then I would probably reduce by 6 here. 6 would go into both of those. It looks like it's going to be 5 pi over 3. Now, if you wanted to check this, if I want to check this and see if this is correct, then I would just do what we just did on the other, the previous two examples. You could just substitute 180 in for pi. So you could just say 5 times 180 and divide by 3. And of course, 5 times 180 is 900. And 900 divided by 3 is going to be 300, which is what you got up here. So if you ever want to check one and say, is my reducing correct or did I reduce correctly? One way you could do that is, go back through the process of changing what you think the correct radian is to a degree. Okay. So there's one example. We'll do another one before we change topics, and then we'll go from there. All right, let's go with just off the top of my head here, 70 degrees. Okay, so to do that, you would say 70 times pi over 180, and you're going to reduce that, chop off the zeros, and of course, 7. Of course, this 7 is prime, so you're just going to leave it like that. So this will be 7 pi over. It's going to be 7 pi over. Oh, hang on a second. 7 pi over 18. And then if you want to go back and check, you could sub in 180 again. So if I were doing this one to check it, I'd say 7 times 180 over 18. And then 180 divided by 18 is 10. So it'll be 7 times 10, which is 70, which does match what we started with, the degree measure. All right, guys, moving right along. One thing that we want to talk about next is all our trig functions, okay? So all the trig functions that we know are sine, cosine, and tangent. And then there are these other trig functions, which some people call the reciprocal functions, which are cosecant, secant, and tangent, okay? And of course, we know it tells you how long I've been in. It's not tangent, okay? That was so bad wrong. This is cotangent, okay? Sorry about that. So all of these have proportions that go along with them, okay? And there's a bunch of different things we were supposed to remember. So we'll just start with the one that I like to start with, and I always like to go through tangent to get these, okay? So tangent is rise over run, okay? So rise over run is y over x, okay? Or delta y over delta x. So, and we also know that tangent is sine over cosine. So if you ever forget which one is sine and which one is cosine, this right here will tell you. So tangent tells you really what all these are. So that means that sine is y and cosine is x, okay? And then over here to the side, you've got cosecant, secant, and cotangent. And then I'll go through cotangent with this. Cotangent is just the reciprocal. So these are the reciprocals, okay? Reciprocals of those functions over there. Or some people mess up and say the inverse. They're not really inverses. They're reciprocal functions, okay? So cotangent would then be cosine over sine, which means that's going to be x over y. And then secant is going to be the opposite of this, which would be 1 over x, or what we like to use is 1 over cosine, okay? And we've used that a bunch in class, and you will use it next year a ton for those of you that take calculus, okay? So that means that cosecant would be 1 over y, which is going to be, sorry about that. I hit a button there, which is going to be 1 over, let's see if I can get this in here. 1 over sine. And you may have heard this in class or heard me say it, that S's go with C's. So that's just one way to remember that. Sine's reciprocal function is cosecant. Cosine's reciprocal function is secant. And, of course, tangent and cotangent are going to go together, okay, no matter what. You can kind of see what they are, okay? So those are your functions. And, of course, in the packet we're sending home, we're going to talk about how to use that. And I'm going to do one actually in just a second concerning the packet and concerning, how to do the problems in the packet. And if you listen to the notes, then you should know how to do all of that, well, the majority of it. And a lot of it, like I said, is just review. All right, so here we go. So we've got, this is one of the first questions in the packet that we're going to send home on Friday. So here's one of the first things you'll see is you've got to take a sign, or you got to take a function, and you've got to take it all the way through, and you've got to find out the value of each trig function. Okay, so we'll start here with this one. Sine of pi over 3. Well, this is in radian measure. So if we don't have the unit circle, which you probably have at home, you can look at the unit circle and get all of this. Or if you have a calculator, you just have a calculator, this is what you need to do. I would probably change this to degrees. So this is the same as sine of 180 over 3, which is sine of 60 degrees. Okay, so then you just need to find the sine of 60 degrees. So the sine of 60 degrees is going to be what? Well, if you type it in a calculator, it says 0.866. And that was one of those things that you were supposed to remember. So what is 0.866? Well, 0.866 is the square root of 3 over 2. So the sine of 60 degrees is the square root of 3 over 2. So that's the first thing you have. You got the sine of 60 degrees, which is square root of 3 over 2. So I got to keep going through all of this to find the other things. Well, if you got your unit circle, you know what the cosine of 60 degrees is going to be. And what is that going to be? Well, if you type it in the calculator, 60 cosine, that's 0.5. So this is 1/2 right there. And then you just keep going. Now I got to do tangent of 60 degrees. So 60 tangent is going to be 1.73. Well, what is 1.73? Well, if you got your unit circle, you know that that is going to be what? Well, 1.73 is the square root of 3. So how do you get square root of 3? Let's talk about that just a little bit, okay? So I'm going to take some time and talk about why this is square root of 3, okay? So here's why it's square root of 3. Well, if you remember on the previous deal, tangent is sine over cosine, okay? So this is square root of 3 over 2, which is sine over 1/2. And I know that's kind of running into that. So just think about that as a fraction over a fraction, okay? And if you got a fraction over a fraction, then that's going to be, take this to the top and multiply by the reciprocal. So this will be square root of 3 over 2 times 2 over 1. And then my 2's cancel out, and it's just square root of 3. So that's how you got that answer. So square root of 3 over 2 is sine. 1/2 is cosine, and tangent is square root of 3. Now, if you got your unit circle, of course, you can get all of these answers just by looking at the unit circle. Now, to get cosecant, you're going to say 1 over sine. Well, sine is this. Well, here's why they call these the reciprocal functions. You can just take the reciprocal of that fraction. So this will now become 2 over the square root of 3. We all know that that's no good because you got a radical in the bottom. And I would probably take the time to rationalize that square root of 3 over square root of 3. So it looks like it's going to be 2 square root of 3 over 3. So that is the cosecant. Okay, so now we've got sine, cosine, tangent, and cosecant. Now we've just got 2 more to go. Secant. Well, secant is going to be the reciprocal of cosine. Well, the reciprocal of 1/2 is just 2. So that one does come out pretty easy there. Okay. Now, what about tangent and cotangent? Well, they are reciprocals as well. So this is 1 over the square root of 3. And of course, we can't leave it as a square root of 1 over square root of 3. We got to rationalize. So we got to multiply by the square root of 3 over the square root of 3. So it's going to be square root of 3 over 3. And I think that is the first two on the packet that's being sent home. Let me check and make sure. And yes, those are the first two questions that's being sent home. Now, the radians may be a little different, and you may see something that looks a little more complicated. But if you've got your unit circle, then you should have no problem getting those answers, okay? Just use your unit circle to get those and use your reciprocal functions.